Hello, John. I'm not going to ask you a question. I'll ask later. I have a question about the experimental petrology. So on the high titanium basalts, you suggest...
You mean me?
Yes, you.
Okay.
You suggest that there could be up to 6% creep that's mixed
Yes.
into them, which satisfies the rare earth element constraints. The high TI basalts, though, don't have an isotopic creep signature. They've got, in terms of things like neodymium isotopes, they're not particularly creepy. So how do you reconcile the trace elements with the isotopes to suggest you can have so much creep involved in their origin?
Actually, I'm still consider about this question because as the previous literature suggested, they majorly choose the first step. They got a low degree of partial melting and relatively low creep trapped into the But as I said, this process actually is not consistent with my major element experiments. So I did the second step to satisfy the major element experiments. And for this question, I think I need more time to think about it. Yeah.
Okay, something fun for next steps.
Yeah.
Thanks. Yeah, thank you for the presentation. It's very interesting about the cores. So you use like a titanium zircon thermometer to calculate temperature for like a core. Yeah. So oh, that's published data. It's not from your okay.
Yeah, so people that use titanium quartz, that was published data. We're just sort of saying that they sort of agree with each other.
Oh yeah, so actually for this kind of thermometer, I'm just like you mentioned that. So there is no rutile, so it's not direct. Should not directly use that and thermometer to calculate the temperature. So if you use that titanium zircon thermometer, you have to find the rutile. We'll make sure that titanium is saturated.
Yeah, so rutile is an interesting point. Yeah, so we assume no rutile for the moment, but yeah, that I guess we'll have a bit of variance there if you consider rutile as well. Yeah.
Oh, yeah. Thanks.
I had a question for you, John, and I'm sorry, I don't recall your...
Yeah.
Sure.
Yes.
About the depths, both of you alluded to the depths.
The depths.
Origin, yeah. I didn't see on your plot, or maybe I missed it. What depth did you say the high titanium metals might have been produced? Because you said shallow depth, but you didn't put a number on it.
According to the previous experimental results, maybe it's from 80 to 100 kilometers depths.
Okay.
Yeah.
Okay. Is that consistent with what you are trying to reproduce? I thought they were deeper than that.
Yes, I did the experiment at the 0.5 GPa and at the pressure gradient in the lunar. I think it's consistent with each other.
Okay.
Yeah.
For John, the depth one is a bit puzzling, that we can't get the handle on. But I wondered whether we can actually use the so-called granitic class in Apollo collection as an analog for these Gruithuisen dome material, because the two may be quite...
Yeah, I agree. I don't think they're necessarily linked. So I think and I guess as part of the package of work that we're trying to do eventually is to try and figure out, are they really? And I think, the evidence basically from what I've seen is on the sort of the point that these things, that Apollo might have been shallow since there's tridymite, and therefore it could be similar to the silica domes. But I don't think that link, as you say, is necessarily correct. Yeah.
Yeah. And what was very striking on your plot is that the Cedillo et al. Data, that was so different to anything that you are actually measuring. I mean, did you both look at the same type of samples, or are we looking at...
texturally, yeah, they're very similar. Yeah, so I guess he had some slightly different Apollo 12 ones. I guess we've expanded it to a few different other Apollo landing sites, which Steve Cedillo didn't look at. But I think fundamentally across the different Apollo landing sites, texturally and in terms of the major element chemistry anyway, they all look fairly similar. There's nothing particularly different.
But not on that plot that you showed. I mean, the video plot was everything.
So that was just a few crystobolites that he reported. If you look at most of what he calls quartz, actually overlaps quite nicely with what we see. It was just that we didn't really see very many crystobolites, whereas in his samples he had quite a lot of crystobolites.
Okay.
Great. Are you seeing any textural evidence of the phase transition between 3D mite and quartz? Or maybe you can look at a smaller scale.
Yeah. So again, this is another interesting question. So another part of evidence that people have cited that you have this decompression from these high pressure polymorphs to low is this so-called Haeckel's texture. I don't know if you've come across this, where you've got these very fine cracks in the silica. And what's interesting is that some samples show that, other samples don't. So I don't think we could necessarily, I don't know much about that texture and if there are other ways of producing them necessarily. I think perhaps shock, you can maybe argue, could reproduce some similar textures. I'm not too familiar with that necessarily, but it's certainly really interesting because some samples that don't show this Haeckel texture do appear to be quartz. So whether they've been decompressed and they just have for some reason anomalously high, TI, yeah, that's a good question.
And any solutions of TI in the quartz?
No. I mean, they all seem to be quite. I mean, rutile isn't a phase that we really see. I mean, there's a lot of trace zircon, a lot of trace phosphates, but yeah, there's nothing that's particularly TI rich. Yeah.
Thanks.
I've got one for Roberto. So you said the microwave was probing deeper level that UV, for example. What's deeper level? Are we talking a meter, 10 meters? Do you think we can see the bedrock basically, or is it still irregular?
Well, there is a big problem with microwave. That's why it wasn't widely used. I mean, there is another reasons because essentially is the dielectric properties of titanium. So that basically, if there is very high, it's a screen. So the potentially is relates to the wavelengths and all that, the basic physics parameters. But when I looked at the far side, as most of you know, and the titanium levels are very, very low, even bordering to zero, then I am confident we're looking quite deep at those frequencies. Here it's again, that's why not many people are published on the near side, because you need to unscramble. That's why, unfortunately, my chaotic presentation didn't make very clear, is the relationship with the rock abundance, which is very important. And obviously, the rock abundance, that's the exciting part, because the rocks is not, infrared can look at the rocks on the surface, I think down to about a centimeter maximum. But obviously, regolith contains much cohesive materials, and there we cannot see them normally, unless you use radar, of course, which relates to microwave anyway. So the short answer, which I should have said before, in an environment where the very low titanium, yeah, you can see up to meters in depth, which is very exciting. In a place like where we're all looking at the Apollo area, whatever you want to call it, then try to unscramble. That's what I use 20 different parameters to have a look what we're actually looking at. Why are there these hot spots, or whatever you want to call them, of microwave reflectance or radiance, to be precise, or brightness temperature, relates to actually geophysical parameters. And I think we're getting there to unscramble it. But maybe the solution is not there. Not everything in science is going to have a definite answer. Maybe just that's the most information we can get out of it. Thank you.
Any more questions? Well, in case you want to cogitate a bit more, I just had another question for you, I suppose. Does water have any effect in terms of microwave? Yeah. There's not enough to sort of quantify water or...
No, actually, there is research. That's the exciting bit. The microwave data from the Chang'e 1 and 2 missions is they're trying to use it at the polar regions. Of course, that is the hot cake. Unfortunately, the data there presents some problems with the calibration because of the latitudes, as again, many of you will know.
Thank you very much. So any more questions? So basically, I guess we can probably wrap up the Q&A there.